So we just go now, and you will see we already live capturing.
Oh wow, that's fast. We're gonna have 3D print you tonight.
Hello.
Hello, good morning.
What do you got?
I got cheese and cranberry sandwich.
Cranberry? Cheese? What's up with all the gains, man?
I need to wake up. I need energy for the 3.5 hour drive.
Okay, 3.5 hour drive to Stuttgart because we're picking up our newest... No, not AMG or GT3 RS or something. We're going to Shining3D. Shining3D is a scanning company that you may have seen in one of the previous videos when I visited Rimac, the factory of Rimac Automobili. They use that scanner as well. Bugatti uses it as well. Lapo uses it as well.
Yes, they do.
Although a bit less,
the base model.
bit more base model.
Yeah,
not
but it's really good for what it is. It's really good product. So we're gonna go right now. I get the new scanner for the company, and it's called the FreeScan combo, which is basically a combination of scanning and also for having the geometry, but also for product development and quality control. So we're going to be able to scan for modeling and doing what we do, and also if someone wants to come and wants to see if their product it's good and if it's back, we can scan it and see if all the tolerances are correct.
Yeah, amazing. I got a bit distracted by the construction works that are taking place here at the Nürburgring, the preparation for the season that will kick off exactly in 1 month time from today. Anyway, let's get to Shining3D, see what it's all about. I'm very excited because, as mentioned previously many times, this is all new to me, so I'm very curious and eager to learn along the way, and let's scan some stuff. Unboxing video.
Yes, unboxing video.
Fast forward, we obviously made it to Shining3D, and I made a joke, we're going to Stuttgart but not to Porsche, but look, here's actually half a Porsche Boxster. Maybe we get to scan it.
I really like the box.
Yeah. Imagine customer comes to us, yeah, I'd like to scan a car. How much it costs to scan a half a car? And they deliver this.
That's what you get.
Yeah. Oh. Pulp Fiction.
Yes, and we have here the welcome letter.
Ooh.
The certification of the scanner, so really important that it's certified by our lab here, and we certified 2 times. 1 time in China and 1 time in Stuttgart here in our laboratory. So what we do is basically we're gonna measure an artifact over a certain period and over a certain time to get the values, and you see it has to be within the 0.035 millimeters in total to pass the test itself.
So I want to give a scale of what maybe people that aren't too acquainted with the measurements.
Yes.
When you do basically, if you have a normal bolt, the tolerance around the bolt is 0.5 millimeter, and this is 0.03 millimeters for the tolerance.
Yes, and even the highest you can reach is 0.02. But as we scan 500 millimeters, we have a volumetric.
Of course. So it's going to be
pretty accurate.
Yeah.
Yeah. And I guess for aero, it's very important.
Yes, actually, it really is.
Then we have the scanner here itself, so fully aluminium. That's also why it makes it really durable, and the heat management pretty well.
It looks small, or is there anything extra attached to it?
No, that's just the cable stator, which...
Because some pictures I imagine it to be like really, and usually when I... Yeah.
It's even cooler because if you can put all this power on a smaller package, it's going to be easier to put it inside small crevices if you're going to do it underneath the car or the wheel well, so you have brake ducts, brake cooling, brake discs, so you can go behind it. And so yeah. Of course, you're going to have the PC to run it, but...
Yeah, for sure. No, but this is important.
Yes.
Especially if you need to scan a lot of things.
If we're going to go around with the small package, we can go have it in the airport with no problem.
Yeah.
So yeah.
Even one more plus.
You want to fly us out somewhere? We're due for a holiday. We haven't started even yet, but when you look at the average weather in Germany, we should...
It's great.
Yes.
which is good for scanning.
Oh, is it?
Yeah.
More on that topic in another video.
Even true. So we have here a little bit more. So a tool to remove the markers. We have. I wouldn't use that on an expensive car, but
No.
we have here small markers, so 3 millimeters, and we have here a protection for the scanner, so you can put it down there and then around your wrist that you cannot drop it.
Yeah.
Reminds me of the Wii controller thing.
Yeah.
that you don't eat it into the
Because
screen.
no one ever sent a controller of the Wii.
No.
It's to be broken.
Yes.
Yeah.
And it's like a lot of markers for you to scan the cars. They're in here, and all of that you can find in the back up here. And then we have the cables and the power plugs. So 5.2 meters. Then we have here the power supply. Not really power supply. What is it called in English?
Yeah, power supply.
Yeah,
Power
it is.
supply.
It's power cable. Yeah.
Because we have that's I would say more the power adapter then,
Okay.
which you will plug the scanner in. The heart of the scanner is under this one over here, so we lift it up, and then we have the calibration board of the scanner.
Yes.
So each scanner has his unique calibration board for sure, and that's also the reason why we have the high accuracy for the scanner itself.
Awesome.
Nice.
So how many times do you need to? Because for example, I used, as we talked, the Instar. And I used to do it like every couple of weeks. With this one, it's going to be the same.
Yeah.
Okay.
So we would normally recommend if you use the scanner, if you take it to another place or if you scan outside, there's a temperature difference. As we have talked about the measuring device here, let's try to run the scan a little bit, get it used to the temperature, and then calibrate it. We have a temperature sensor included in the scanner, so you can always read out what temperature the scanner has. And we also give a value. It should be between 25 to 35 degrees the scanner itself.
Okay.
And then calibrate it. So if you have it in your workspace and it lays there, same temperature almost, calibrate it once per week.
Yeah.
Should be good. But if you move the scanner to another place, the parts can move inside. So recalibrate the scanner.
Perfect.
Okay, quick fast forward. Everything is now set up on the laptop, and we have here the mirroring of the screen. So we have laser mode for all the 80s goodiness, and the IR mode.
Yeah. So can you give us a bit of a rundown of like which other modes should be used in which case scenario? Yeah.
So what we say, especially for the car industry, the laser mode is normally for the exterior. So if you scan everything outside, and the IR mode is more for the interior. So if we have a lot of features, a lot of details to scan the part, then we use the IR mode to capture the data and bring it together. But the laser mode, as it has the highest accuracy possible, and the laser where you can scan reflective, shiny.
Yeah, that's exactly. So sometimes I have problems with, like, as everyone has when you do scanning, black parts. So with this, let's say, system, you take out that problem, so you can scan any surface that it's not super reflective.
Yes.
Or like, for example, glass. You're gonna need to spray it and find a way to not make it see-through. So, but with laser mode, you're gonna be pretty much set up for anything you can throw at it.
That's it. The first thing we're gonna do is, we talked before about it, it's the calibration. So as it's a totally new device, it's also not calibrated the first time. So we will go on this calibration button, and then you will already get the instructions itself. Yeah, it's pretty straightforward. It's almost the same like the Einstar. There's only one more step you have to do, and that is the calibration of the 7 laser lines. So we have 7 laser lines parallel. If I go on, you will see it. So 7 lines, and we have to calibrate as well. You see, it's super fast itself. And you see the pictures, what you need to do to tilt the scanner itself.
That is fast.
And just hold it in the right direction. I have to do it only right. Whoops. There we go. And then here. And normally you have it calibrated within seconds.
It takes 5 minutes with the other one.
So that's basically GD3 RS amongst scanners.
Yeah.
That's nice.
Yeah, now the thing you will also see the difference will be the calibration deviation, which will come out compared to the 1 star. So it will be in the micro area. So we are 0.009 millimeter. That's the pixel error we get from the calibration. If this would exceed the 0.02 millimeters, which is our profile tolerance for the scanner, you will fail the calibration and maybe you will have to ship it back and we have to do factory calibration.
Okay. Good thing that you're close.
Yes. That's good. So we also have a pretty cool function there, and it's pretty new. So if you go on the setting buttons, you can first of all choose in what language you want to have. We have almost all the languages possible, from German to Poland to French. You can choose the scanner tone, so how like noisy it should be. I like it a little bit lower normally. The shape detection optimization, so that if it recognizes a shape, you can automatically recognize it and optimize it itself. The laser indicators I can show you later, and you can always recover it to the factory calibration.
So with the shape detection optimization, for example, if it sees, let's say, a cube, so it's going to reconstruct the shape as a cube, let's say.
Yeah, that's one part, and one part is for sure if you scan a flat surface, you recognize that, and if you use the feature alignment, so not the markers, it will tell you like, hey, you want to scan a flat surface, you need to stick some markers. Okay. And it doesn't allow you even to scan, otherwise the accuracy will be not correct. I always, if you scan a little bit, you normally don't need it anymore because you recognize by yourself. We have also here the help button, so if there's any question regarding the scanner or any problem, we have a system diagnose, so we check live if all the drivers are correct of your computer or if you have to update one. And we have the support line here, so if you have any technical support, you can immediately get a team viewer with us together, or you can submit a ticket here from the system.
Awesome.
Nice.
I think the first mode we can show over is the IR mode, so IR is the infrared. The beautiful thing, no light is needed there, so we can scan without annoying another human or another person even. So we go here, we create a new project.
So this example, if we want to scan maybe pancake, we should use...
Yes! So we can...
Keep them still.
That's it, so we can say now we want to scan a portrait, that's normally what we think is a human person. Why do we call it like that? We have an algorithm included which can recognize the movement of the person. So if you brief, there will be normally a deviation, and we can calculate it out with our algorithm we have. So we can once try that out. We go on apply. So we just go now, and you will see we already live capturing.
Oh wow, that's fast. We're going to have 3D print here tonight.
This wouldn't be a big problem. I think for a whole scan of a human, normally I would, 30 seconds. If you do it really fast. Let's see.
It's Misha.
And you also see the different colors.
Yeah.
So they give you an indication also. If it's yellow, you should maybe go one more time over.
Okay.
To capture a little bit more details.
And there you go.
Okay. I think that's it.
That was like what, 1 minute less?
So if you guys want a mini,
I always want
mini
to be
Misha.
cloned.
Yes. So we have it here. It's currently in the lowest resolution. So next step we're gonna mesh it to an STL file, and then we're gonna see how the real file will look like.
Yeah.
And we can close also the open holes.
Yeah, let's show the system.
The mesh, yes.
Yeah. So how you can like patch and smooth out the
yes. And you can even we choose a resolution of 0.1 millimeter, I think so.
Okay.
Or 1 millimeter.
Because
1 millimeter.
That's what. No, it was 1. I think.
1 millimeter. Yeah, 0.1 is way too high. 1 millimeter, and you can also go a little bit lower and even get more details of the face, for example. The another thing you can do here is, maybe you saw it over here, the function, it's the working distance.
Yeah.
So you have the same for the install. If you want to go a little bit further away, scan a huge area, you can increase the working distance, get a bigger scanning area, and then scan the part, which I really like. If you have a difficult area, you can normally increase.
And so as the other one, you have buttons here, right? So
yes.
You're gonna have, now with the light it's a bit difficult to see, you're gonna have plus and minus? Or?
Yes, yeah, and here we don't have plus and minus, we only have the arrows like in the direction. So here you can zoom in, zoom out, and hear the brightness. So that's normally what you learn, or you can open up the tutorial here when you click longer on the scanner itself.
Cool.
So yeah, we see here the first result of the scan, and I would say that looks pretty good. I missed here because I didn't scan there, but the software will close it automatically in the next step. So what I can do now, I want to delete maybe the flow over here, so I make a small cutting plane.
So this we don't have on the other...
I think you should have in the newest updates.
Okay.
So, and the beautiful thing, if I have once the cutting plane created, he will never scan again the floor. So if I would rescan now only the shoes, I could do that and without capturing the floor itself. This takes a second, and then the next step, as we only have points now, so we have a point cloud, so you can measure with that, but most of our customers, they will use the STL file.
You can do, which files can you export?
In this software you can export an STL, OBJ, unfortunately there's no texture, but you can export an OBJ, FreeMF, and the STL for sure, and the SD file for the point cloud. So I can just show that. So we see now, if I zoom in, all the small points over here, and the idea is now, we call it a mesh. That means from the small points we will create triangles.
Yep.
So we will connect those little points. Next step, we're gonna go here watertight, and now we're gonna mesh the whole file. Watertight means ready to print.
Yeah.
So no open holes left.
That's going to be useful if you want to like do a small, for example, a small scale down version of a car. Maybe then just add our elements as an STL file. So we're going to have the basic scan with our parts already ready to be printed. And now it's basically reconstructing the surfaces that there were holes and making
a mesh. Yes. The finished file.
That's really good.
You see nice. Here where it closed the hole, so you see a little bit that we didn't scan here. But if you would 3D print that in small,
we're gonna do the whole thing.
Yes.
Scan,
You wouldn't even.
But to be honest, for being reconstructed, it's pretty remarkable.
Yeah, the auto fill up, and this was 1 mil, right?
Yeah.
1 millimeter scan. This is wow, crazy.
You see a little bit here that as we use a little bit higher brightness, you see a little bit that the texture of the shirt is there a little bit due to the different color. The watch you can see a little bit, but as it is glass, as we discussed before, it's hard to capture everything.
So on the left you have all the all the
parameters.
You can decide how big the mesh is, and
you can even do that now. If I finish the scan, I can even go on simplification. As you know, it's 180 megabytes, so this would be a little bit too much for me. So we normally, one of my colleagues tested it a long time, and if you reduce up to 50%, you will keep still the accuracy. If you do more, then it can be kind of. But for a human scan, it doesn't really matter.
Yeah.
And we see still, I reduced by 60%, and it looks the same.
Yeah.
Then we can optimize. That's, for example, if we see sometimes a little bit of the not a nice surface itself. They could be due to the texture, or the color, or the surface itself, really. So I could use this a little bit up here, apply, and then he will reconstruct the surface and maybe a little bit more smoother. Make the edge sharper, and just looks a little bit nicer, the file.
So this is also maybe in the let's say automotive sector. If you have a panel and maybe for some reason you have a bump where you mesh optimize it, and it's gonna smooth out the imperfections.
True. Yes, that's also one thing you can do. Another thing you can do, for example, if I don't like the watch here, for example. I can confirm that once. I have here the function select visible or select through. I want to only select visible. I could now go on this part, for example. Could just delete it out, and then I could go myself to close it again. So I can defeature parts. So manual hole filling, and then he will ask me if I want to have it closed with a curvature and with a tangent or flat. So I will use tangent here, and he will close the surface now. He did a little bit weird because of the I didn't delete everything out here. You see there's a little bit of part left because I used the select through. So
it's basically like Photoshop with a magic eraser tool. If you don't do it correctly, it will just add some.
We don't want the spot here.
Yeah, you're gonna put a car in your face if you don't do it correctly.
That's for sure possible as well. Yeah. The other things we can do, if we want to do, we can also measure shortly. So a really easy measuring tool. We can for sure measure the distance. So I can say I want to measure from the foot here to up here, and I would have 177. Or
we needed to measure ourselves for the seats the other day, for custom-made seats, and we're like with measuring tape, but now we'll be like.
That's kids, you know, you go to the wall.
Yeah, that's what we're doing.
Each of us would like. I'm a bit tired with and putting the line on the
So you can even export the data then.
Nice.
But yeah, now I didn't use the full, so you're taller, so not your real height here. But we can also measure the surface area. So you can go on a surface area and calculate it itself. For the volume, you have to have a watertight model.
Of course.
As I now kept this open here, it will not work anymore, but this is also possible then.
Nice.
Sometimes you have the problem that the file is somewhere in the in the room, and you have the coordinate system, and you have here the functions to create features. So I can select a point, for example. Let's use it here, and then I can select a line. Maybe we're gonna use the line on the forehead. Make it easy from point to point, and then we're gonna use a plane. Maybe I make the other leg here, or the foot. Best fit, and we have a plane. Close that and go on the measuring tools.
You reselect all the points.
Yes, and go on the line button, not the measuring tool. 3 to 1, and I can say like use the plane, use the line, use the point, align. And now I have it. Now I have the whole scan perfectly in my coordinate system. If I don't want to make those kind of movements or create those features, I can also go on the quick alignment. We have that a lot for orthopedic customers. You can just move the scan in your right position, click on a line, move, and close. Then you can also line it really fast.
It's going to be less, let's say, accurate, but if you want to have it in, let's say, around that point, it's going to be good. Okay.
Yeah, that if you maybe want to print it, then you don't have to move it from the printer already. You can have it kind of in the same coordinate system as the printer.
So now basically, if it was watertight, only for that problem there, but with a watertight STL file, you can go directly on the printer.
Yes, so we can go on the save button here, and then we see again all the different file data we can export here. So the ASCII, so that's the point cloud, STL, OBJ, PLY, and the FreeMF. And I can already save all of them. A FreeMF normally, if your printer supports it, it's a pretty good file format because you don't have the interceptions in it.
Yeah.
If you have another software, like a third-party software to reverse or to inspect, you can also open the file
directly.
Yes, so we couldn't inspect Misha now to a CAD file, but we have to create one still, but it would be possible. And that's, I think, the beautiful part about the IR mode. So no need to prepare anything. You can just start immediately, and you can scan even a little bit moving objects, or even the interior, or like where you have a lot of features. Perfect. Really fast.
Nice. So maybe also, for example, the engine bay would still go on the. Which one would you choose, the laser or the IR?
So it depends there for sure. If you want to have the highest accuracy, I would choose the laser. But if you say the engine bay, you want to design something to it, or you want to make a new design or a new top, then the IR mode is normally enough because you just construct around it.
Perfect.
and not really with all the details.
Maybe it's something we can see when we get there.
Yes.
Cool.
Sounds good.
And then we can also switch back to the laser mode. That's that mode over here. And we can create here a new project group, so we call it T2. And now we're gonna jump immediately into the scan. And you will see the difference here. We already get the information, hey, you wanna scan outdoor. So we know a lot of customers that need to scan outdoors, or you're really fast, you wanna on the track, you wanna scan a car, you don't wanna drive it into the shop. So you can activate this function and even scan outdoors. You can choose the brightness of the scanner, so if it's really bright outside, you may want to lower the brightness of the LEDs. And we can choose, we want to scan the markers first. So what does that mean? So we don't scan the fiber immediately, we scan only the marker points first of all.
Okay.
So we capture the marker frame and then we're going to build up the scan on top of that. Why? We can increase the volumetric accuracy for this.
Yeah, because with big, usually when you get big scans, if you go around, you're gonna even if the scan looks aligned, you're gonna have some deviation. So with scanning the dots before, you're gonna have an accurate let's say map of the scan area. So when then we go and scan the surface, the mesh, let's say the point cloud, it's gonna reallocate everything where it's supposed to be.
Correct. So we can just do that now. So we could create now the marker file.
Yep.
So you would just use the scanner. You want to try it?
Yeah, I'll do it.
Yay! Lapo gets to play with his toy.
Yes.
Also, this a little bit closer to you. Okay.
We'll do this.
Yes, we can just do wherever the markers are now because I chose the marker.
Okay.
So you can press once start.
So in the middle?
In the middle, yes, once.
So I'll start here.
Yes, press once. And now a little bit further away. And now you're capturing the markers.
Okay, so basically the green, I'm in the right position.
Yes.
So if I go too close, it gets red.
Yes.
Okay, so very close. And blue
It's too far away. Yes.
Now, and it says also here, too far.
Yeah.
Yes, and over here you also have the indication.
Yeah.
So now it's populating the map.
Yeah, a little bit further away. Yes, or back to the screen because you didn't.
It's a bit awkward now because I can't.
Yes, you don't see the screen.
So let's do it like this. Let's see.
It's pretty good.
Let's see.
That's really quick.
So now we are done. So I go on scan mesh, and the resolution is 0.5. Let's keep it, and then you can just start scanning again.
So for example, if I have an area which I didn't put enough markers,
yes,
I stop it, add some in some
yes,
places, and then that's nice. Okay. So I'll start back up here. And see
yes.
And then,
you see the laser already, and now you start scanning.
So here.
Yes.
So you see,
you can just
usually with the other ones, you go here and it loses.
Yes.
I go back here.
Immediately he finds himself. And you see the difference now here? You have the laser line, so the laser line gives you the indication how close and far you are. So green is the perfect distance.
Here to see.
Yes. And don't worry, you can really go fast with the scanner.
I'm used to it. Oh no!
Yeah.
I'm gonna lose tracking. Okay, now I'll go back up. So this is really amazing.
Yeah.
Just it eats everything.
It's hungry.
Yeah.
It's already STR file.
Wow.
So right now you can go and save and already save the STR file.
So it's already processing the data while I'm scanning?
Live mesh the part itself. So it saves a lot of time for you, and the most beautiful thing over here is that if we see here the resolution, and if you see now, maybe it's a little bit too much, or maybe you want to have even more details, you can still change the resolution and re-mesh the part. So now it's applying the new resolution, so you can maybe first of all scan it in a
So let's say I want this part to be really accurate. I can, in the same project, I'll go back and rescan it.
No, now what I do is I mesh the whole part new. But I'm going to show you the next thing you can do is you can redefine areas. So what you do is maybe here we have an interesting part of the welding, and we want to check that. And later on we go on this part itself, and we want to redefine the area, make it even more beautiful. So that's the next step what we can do. Because now I choose 0.3 millimeters, and we can maybe go on 0.1 for the small part to see all the details.
You're like a kid on a Christmas evening. You're like, oh my god, the best toy!
It cuts down all the time. That's it. It's incredible. So the jump from this to the one I'm used to, it's even if they install it for the price, it's amazing. I've used it to build stuff, and this is gonna be
game changer. It is. No, because you were saying to me like it would take you usually like half a day to a day to scan a car, but now it's going to be a few hours.
Start to one place, then maybe it loses tracking. But this is each stuff, and we're gonna go like really fast with it.
Amazing.
So remesh with a higher resolution now, and let's assume we wanna redefine this area here. So I would just now go on the partial HD scan, go on the area here, and say I want to have 0.1 millimeter resolution, accept that, and then you can take the scanner again, and you will recognize one thing, you will change from the 26 laser lines to 7 laser lines, parallel, so you have to go a little bit closer in a second, a little bit closer to the part, because the distance is a bit closer to capture even more details.
I'll go closer.
Yeah, yes.
There it is. So now I just need to clean it up.
Yes. So now it also takes a little bit longer than normal, but it's just that we scan so many points now per second. Yeah, pretty good. I think that looks pretty good.
Yeah,
it's already done, yes. So if we now would zoom in, we would see the difference in the file itself. From here to here. 0.1 millimeter details compared to the file size when you use 0.5 millimeters.
It's basically going from HD to 4K.
Yes.
Yeah.
Kind of, yes.
Yeah.
That's the main difference if you scan with the HD scan mode.
Nice.
So now basically we're going to do different modes for this type of scan, right?
Correct.
Still it's going to be laser.
Yes, still be laser.
So let's see. We did the markers, which was the same as for the Porsche, and now this is the preview mode. So I know that everything is aligned. Now I press play, and it's already scanning. So I'll show you how fast it is.
Crazy.
Yeah. And now if I press the play button, it will change to...
Now I have 5 lines now, so you can release it. And so for this you have to really close, yes.
So now this is the same basically for accuracy, right?
Yeah.
So if I want this part to be fairly accurate, not really accurate, because it's really pretty accurate, I can go there and... And if I want to be even more accurate, I can keep press, and it's going to go in single mode. So if, for example, I want this hole to be, really detailed.
A little bit further away until the screen.
Okay.
Yes.
So if I want this hole to be fairly accurate, or inside here, and this I'm going to create inside there. Okay.
This from here. Or in here it's even possible then to scan really down there, yes.
The inside areas.
Yeah. Yes.
So this is one layer mode, one line mode, closer. Oh, sorry.
Just a little bit further away then.
Okay.
Yeah, that's it.
So this is gonna go and create all my... That's fine. Let's go back to the normal one.
Yes.
So now I'll go back. The beginner mode.
The beginner mode, yes.
Yeah.
Yeah, so because for the single line, that's something to really catch deeper into pockets or holes. And what we basically do is, we have normally 2 cameras in the scanner, but with the single line we only use 1 camera to look, so we can really find the hidden areas better. And the scanner can see it.
Okay, perfect. I think we have a model.
Looks pretty good.
So stop it.
And then if you captured anything we don't want to see, we can just go on the scanner, choose the main part and then say connect the domain. So he chose everything which is connected to the scanner. Everything else we're going to invert, delete it out, and we are
So all the noise outside is going to be deleted?
It's going to be deleted. And then we have the file.
Nice.
The same process as before?
Yep.
Now we can 3D print our gearbox.
Yep.
Basically.
Will be nice.
One day, we'll get a metal 3D printer. Post in the comments how long it's going to take us till we can have our own metal 3D printer. And a fast forward back to Vulcan Alpha. Yeah, look at this baby. How excited are you?
Very.
Very.
It's gonna be exciting.
Very.
Yeah.
Aside from the scanner, and yeah, first of all, massive thank you to Shining3D for amazing reception and also for great Indian restaurant recommendation that we went to together with them that you did not see on camera. Unfortunately, didn't make a video. No food shot, I know, but we need to get back into the vlogging side of things. But super stoked to use it. Actually, there's like really endless possibilities. Luckily, we have lots of time to show to you what we can use it on. Aside from the scanner, we also got the necessary...
Yeah, we're gonna be set for at least a couple of cars.
Yeah.
So we have scanning dots and scanning spray.
Scanning spray as well, so ASAP. Yep. And actually you told me that we don't need a lot because thanks to the laser technology we only need just to mask the windows.
We'll probably need only the majority of scanning dots and then the spray is for the windows for transparent stuff.
Nice.
So for let's say lens cover, for cover of the headlights. And yeah, I can't wait to try it on and show you guys.
Me too. To scan everything. We're gonna try to scan Pancake for sure. That's going to be a big challenge. Aside from that, we have received also a couple of more things. We might as well update you as we go. The doorbell, yeah, very important, so we can see what is happening, who is happening. We have also like a filter, and I bought another lens for the photo camera that will arrive, a 90mm, so we can do some nice pictures of product pictures that we'll be making, and close-ups, etc. And dehumidifier, yes, because it's very important to have it. And right now it says 50% already. And actually it's been running, I think, for the last, what, 8 hours maybe?
Yeah. It's quite embarrassing, to be honest.
It's quite...
So, there's like a couple of liters of moisture.
So that was probably a very good investment. We're gonna get also probably some dry controlled environment for all the filaments for 3D printers, because that's going to be very important. Anyway, that's about it. Tomorrow we will be cleaning this all up and maybe unboxing some of the tools from Sonic that arrived yesterday, so stay tuned for that.
The printer.
The printer, oh yeah, as well.
The resin printer.
Yeah. Again, massive thank you to Shining3D for an amazing day. Really excited. And now let's go with the crew. Who's ready for some food? Oh, hello.
But I think all of us.
Yeah, me too, definitely.